This week on the Tech ONTAP podcast, we talked to Dennis Bray of Jetstream Software about how they're leveraging Azure VMware solution with Azure NetApp Files to enhance their Jetstream DR backup and recovery solution.
Welcome to the Tech ONTAP podcast with Justin Parisi.
I love NetApp.
Oh, yeah.
NetApp, I love this company. Support.
I love NetApp because it's so funny.
Hello and welcome to the Tech ONTAP podcast. My name is Justin Parisi. I'm here in the basement of my house, and with me today I have a special guest to talk to us all about what they work on over there at Jetstream Software. So to do that, Dennis Bray. Dennis, what do you do at Jetstream and how do we reach you?
I'm a senior solution architect. I work primarily with new customers. I'm involved in POCs, customer presentations, and I can be reached at dbray@jetstreamsoft.com, or you can just reach us generally at the jetstreamsoft.com website.
All right. Now, the question here is, what is Jetstream? So let's talk about what Jetstream Software does and what's important about it when it comes to dealing with things in the cloud.
Jetstream DR is the software product we have. It's a VMware virtual machine disaster recovery solution. We designed it with the cloud in mind. So rather than take an existing on-premises to on-premises, let's duplicate everything, let's replicate everything, let's just have one-for-one traditional view, it was created with the cloud in mind. So in other words, we would use cloud-based storage technologies. We would use cloud-based targets for recovering the virtual machines. And we would go along with that idea of make things configurable, make them dynamically sizable, work with a minimum amount of resources, and then expand as we needed, and take advantage of the kind of automation and the kind of availability we can get in the cloud that's easier to accomplish than having to have additional hardware being brought in, the ability to ramp up. It also gave us this unique ability to protect workloads without having to necessarily have any compute resources at a potential recovery site or having very limited compute resources at the potential recovery site. And the key decision point for us on that is how soon do you need those workloads to be ready? So if they can be done with a recovery time objective, an RTO that's long enough, you could potentially stand up an entire environment on the recovery side to take those virtual machines on demand. Or more of what we see, there's a pilot light, there's a minimal configuration that will sit there. We can have the virtual machines being protected into the cloud, and we can start recovering those virtual disks and then very rapidly finish that recovery and scale it up when the disaster occurs.
So does Jetstream DR use a proprietary mechanism for moving the virtual machines or backing up the virtual machines? Are you leveraging back-end technologies such as file movers or virtual machine DR, like the back-end for VMware? What exactly does Jetstream do? Is it an orchestrator, or does it have its own little data mover pieces that it uses?
We've got an orchestrator, right? We got a management server appliance. We deploy that management server. That management server communicates with vCenter, and it orchestrates the rest of the components of the solution. As far as getting access to the configuration and the data for the virtual machines, we use the VMware APIs for IO filtering. So with the VIO APIs or IO filters, we have the ability through a driver. So we install a VIB on each ESX host. That VIB gives us the ability to directly participate in the storage path for that virtual machine writing to the storage system. So we get direct access to all the storage reads and writes for the virtual machines. Writes are the thing we're most interested in. So we get that without having to take a snapshot of the virtual machine. We get that without having to put an agent in the virtual machine. And then once we get that data stream for the protected virtual machine, then we replicate it with our own DR replication appliance. We replicate that data into object stores. If we're talking about an Azure VMware solution, we're using an Azure storage account. We also support Amazon S3. We support Cloudian Hyperstore. Just about anything that's S3 compatible, we can use out of the box. If there was something unique, it would take us a couple of weeks to qualify that, and we'd be able to replicate that. So the simple answer is We use the VMware APIs for IO filtering to get access to the data for the virtual machines. And then we replicate with an appliance out to the object store. Now, one thing about that appliance, one appliance is required per cluster, not one appliance per host. We get that data stream from the ESX hosts into the appliance.
Okay. So this is all replicated out to an S3 bucket, essentially, or an Azure blob, I guess you could also do it too?
Correct. We protect the virtual machines by putting them into what we call a protected domain. When we create that protected domain, VMware storage policy is attached to the virtual machine. That's that replication policy that attaches us to the IO filter. Then the DRVA writes out to the object store. As you said, it's S3. If it's S3, it's going to go into a bucket. If it's an Azure storage account, it's going to be a container there in the Azure blobs. And if you were to look at it on the back end, you'll see there's one container per protected domain. And then we have other containers for different aspects of it.
So an S3 bucket and Azure blob doesn't have an endpoint right away for accessing from a VMware data store, I would imagine. So how does that happen on recovery? How does your VMware environment attach to the S3 bucket, or are you moving this somewhere else?
The basic architecture is on the primary site, whether that's on premises or whether it's in the cloud, it's our management server deployed, register with vCenter. The VMware cluster is configured. It uses vCenter actually to install our VIB on those hosts. Then we deploy at least one DRVA. You could have more than one DRVA just to take advantage of additional bandwidth from additional hosts in the cluster, but create the protected domain, assign it to the DRVA, then we write out to the cloud. So for protection, that's it. Just everything that's on that primary site and then the cloud account. For recovery, again, whether you do this on demand, if your RTO is long enough to be able to deploy everything on demand, or if it's an existing environment, similar footprint, install Jetstream, install that management server, configure the cluster, deploy the DRVA, and then you connect it to a storage site. So if you were to see our user interface or see the commands, we refer to that protection location, that storage account, whether it's S3 or the Azure storage account, as a storage site. So we can connect that Jetstream installation to the storage site. And at that point, we can import the domain, scan that storage, see what domains are there, and then decide whether we want to fail them over or not. One thing I'd point out is because we focus on the object storage for protection, these two installations, the one at the primary site and the one at the recovery site, are independent of each other. So in other words, we don't use a linked mode vCenter. Our management servers don't directly connect to each other. Neither management server connects to the vCenter or any VMware infrastructure on the other site. We write all of the state and the configuration information into the object store. And that gives us this flexibility or this ability to restore to any recovery site that has Jetstream installed. The key thing is connect it to that storage site. We'll see the domains listed, select the domain that you're interested in, and then you could perform a failover or recovery operation from there.
Okay. And then on the failover or recovery operation, are those VM hard disks or VMs themselves being physically moved to the new location? I guess you're going to have to require some sort of data movement because I can't see. I mean, maybe I'm wrong. Maybe there's a way for VMware to attach to an S3 bucket, but I don't know that there is yet.
We do this with a recovery appliance. So on the protected side, we have this DRVA. It's responsible for taking that data stream for the protected machines, creating the objects, writing those objects into the object store. It's also responsible for garbage collection, right? When we're talking about object storage, we don't update an object, we replace it. So we keep track of that with metadata for the DRVA. So as enough changes are made to a particular object, we'll go ahead and reread the data, write that object. On the recovery side, we have a recovery appliance, and it's dynamically deployed through the MSA when you start a recovery or a failover operation. So again, it's another lightweight Linux-based virtual appliance. One gets deployed per protected domain that's being recovered, and it's optimized to connect to that object storage, read the objects, and then connect to and rehydrate or populate the virtual disks for the virtual machines that are being recovered. So during the failover operation, we'll attach the storage, create those virtual disks, rehydrate the virtual disks, and as the failover completes, then we'll detach those disks create new virtual machines based on the configuration from the original. Depending on runbook configuration, they'll have the same MAC address, they'll have the same configuration. Of course, they'll have the same operating system and everything else that was installed in them, and they'll power them up. So we replicate the data, reconstitute it on the recovery side, and then bring the reconstituted virtual machines, power them on when the failover completes.
And is there a way to add VMs to priority groups? So if I have VMs I know need to come online first, I can have those go first. Or is there any sort of way you can control that?
When you create the protected domains, we can have multiple protected domains. As a general practice, customers create the protected domains based on that priority, right? If you know you've got certain systems that need to be up before others, it may be there's an infrastructure group or there's something that's got a lot of dependencies. Put those in a domain, recover that domain first. We can set a domain priority. And so if we recover multiple domains, they would be recovered based on a priority that's assigned when they're created. Within the domain, we have an idea of a recovery group. And within the recovery group, we can specify the startup order for the virtual machines. All this is done within the runbook for the protected domain. So we do have a way to prioritize the domains, and even within the domain, we can create groups, and within those groups, specify the startup order for the machines in that domain.
And are you able to exclude VMs? Like if I know I don't need these particular VMs to be backed up or recovered, can I exclude them from those groups?
Certainly, you create the protected domain that will define the container and the like, and then you select the individual VMs. So if you've got virtual machines that you don't need to recover to a recovery site, they're fine to use them at the primary site, but if there's a disaster, they can just stay down, then you can not include them in a protected domain and they'll never consume any space in the object storage, and they won't be trying to be reconstituted on the recovery side. If you had machines that you wanted to protect, but you didn't necessarily want to power them on during the failover, there is an option within the runbook to leave those virtual machines powered off. I'd also mention that for a domain, we would create 3 runbooks. So maybe from a just general terminology idea, we have the runbook as a set of configuration parameters, properties for the protected domain, rather than it describing the entire failover process. So for every domain that's created, we'll have 3 runbooks. We'll have a failover runbook, we'll have a test failover runbook, and we'll have a failback runbook. And the idea there is, as you mentioned, the same set of virtual machines, but depending on what I'm doing, I may or may not want to have the same startup order. I may not want to have all the virtual machines powered on, or I may want to choose a different configuration for the failback or for a test. I know that was a long answer for a simple question, but yeah, either leave the machine out of a protected domain or include it in a protected domain. And then in the runbook, we could select that virtual machine and we'll still recover it, but we won't power it on. So then you could power it on at a later time.
Okay. I hear you use the term runbook a lot. And is there an Ansible aspect to this? Because when I think runbook, I think Ansible.
Yeah. So no, we do have our own automation system, auto automation toolkit. We can create a plan to start protection for the virtual machines. We can create a plan to start a failover, to back up a little bit. I talked about a failover recovery. You could have on-demand recovery where you didn't create anything on the recovery site until you needed it. I said we also could use an existing environment. We have 2 different failover modes. And as I just talked about those runbooks, I mentioned a couple of options, but we have a failover mode that we call continuous rehydration. So basically in this case, rather than wait for the disaster to occur, you would go ahead and start a failover for a protected domain. So you would create the protected domain, you'd assign the virtual machines to the protected domain, they'll go through their initial synchronization. And once that initial synchronization has completed, then the virtual machines are recoverable. Once the virtual machines are recoverable, all of their data, all of their configuration is in that object store. From that point on, we could perform a failover, either a standard failover, that's this case where we do it on demand, wait till the disaster happens, and then we'll start the population of the virtual disks and then power on the virtual machines. Or start this continuous rehydration, where we, in effect, start the failover long before any disaster has occurred. And what we'll have in that case is the virtual machines on the protected side, they're operating normally, they're writing to their disks, we're taking those updates, writing them to the object store, and then we update the virtual disks on the recovery side as that goes. Then when the disaster happens, we complete that failover and we're left just with the interval, the amount of data that hasn't been copied out of the object store to the recovery site. That gives us an RTO of generally about 10 or 12 minutes for that protected domain. So back to the question, no Ansible, but we do have our own automation toolkit. We have a set of REST APIs. Everything we do with our user interface, we actually do through our own APIs. And so if you have an IT service management system and you would prefer to integrate it directly with that, you could use our APIs for that. Could be scripted. With our automation toolkit, we do have an existing framework for connecting to Virtual Center, getting information about the virtual machines you plan to protect. From there, we can propose a domain configuration. We can propose the infrastructure as far as how many DR virtual appliances, what's the configuration of those DR virtual appliances. We'll give you an estimation about the amount of data that'll need to be stored in the object store. And we can give you an estimate based on the IOPS that we observe for those virtual machines in vCenter. We can give you an estimate for the amount of bandwidth it'll take to replicate. We could take that data and create a protection plan with a script or with our automation appliance. We could have it dynamically create the protected domains, add the virtual machines to the domains, assign them to that replication appliance, and start the protection. We can also create a failover plan. So we would run that on the recovery side. We would know which domains, what the storage account to use, and it would also configure whatever was needed on the recovery side. We have a continuous failover plan, and we also have the ability to have a plan for failback.
What's the user experience like with this? Is it a GUI that I go into and point and click or drag, or is it a YAML file I have to build?
So in normal operation, our user interface is provided as a vSphere client plugin. So when we register that management server with vCenter, we provide a plugin there. Normal VMware administrator experience, they would just open their vSphere client, connect to vCenter, go to the data center level, and you'll see there's a Jetstream DR tab, or you could go to just a home and you'll see there's a Jetstream DR item there in the inventory. And from there, you can create the domains, add the virtual machines, create the DR appliances. You can perform failover or recovery. And you also can see from there statistics about the replication rate. You can see how much data we're using in the cloud. That's all done through a UI. The automation toolkit that I mentioned, it's another virtual appliance. And in there is a GUI, so a web application for doing this planning, creating these plan files and executing the plan files. There also is a CLI version there where, yes, in fact, you would edit YAML files. We'll have the template files. The utility will create the information, but ultimately, if you really want to tweak every little setting, you could just go into the YAML file, put in the settings, and then when we execute those plans, it's really taking that YAML file and running it through our script processor.
You also mentioned you keep track of IOPS, you keep track of capacity. Does that get translated at all into cost? Like, are we able to figure out how much it's going to cost me to back up to this device or restore from this device? Do you have any of that built into the product, or is that something that's kind of like future roadmap stuff?
So that's not built into the product. That's what I and the sales team end up doing. Get that information about what you have, get the idea about the total data set size. And if we can get that performance information, so we get an idea about the IOPS or how often this data is being updated, then we can give you that. Or just for basic planning, we can give you an idea about that. So short answer, the product itself doesn't give you an estimate for the cost. We work with the customer or with the partner to be able to do that. No magic in there. It's just math.
Yeah. I mean, generally is, right? And I know that's probably going to be one of the more important aspects of this, because when people start thinking about cloud, they start thinking about cost, and they want to make sure they're not getting into a situation that becomes untenable for them.
So one of the reasons for us to have this planning tool was to be able to give an estimate based on the virtual machines that you've told us you're interested in protecting, their existing configuration and their performance. Then we can give you this resource estimate. So we would recommend it's a certain number of domains, how those virtual machines get grouped together. The customer has control over that, right? Basically can build a whitelist, and they could literally say which VMs they want by name, or we can do a pattern match. And then based on that, we'll tell you the configuration of the replication appliances. Again, how many of them, That translates into how much virtual CPU, how much RAM, how much disk space just for the appliances themselves. And then we'll give you that estimate for the bandwidth required, right? So if we're talking about network gateways, connections out to the cloud and the like, help you to size that. And then we'll also give you an estimate for the amount of object data. So how much would you be writing into the cloud? And then while the system's operating, we have statistics in the UI where you can go see, and we'll show you exactly how much cloud data is being used, exactly how much of the CPU and memory is being utilized by the appliances. So you can help to verify that it's working the way you expected, try to help to keep you from getting a surprise from the amount of resources that are being used along the way.
And earlier you mentioned failover testing. So again, costs being considered. What does it cost to do a failover test? Because in most cases, if you don't test your backup, or actually in all cases, don't say most cases, it's not a backup, right? You can't trust it to be a backup unless you've tested it and make sure it works. So
yeah,
what is the cost associated with a failover test? Because it sounds like there's some actual data movement going on here. So there's going to be egress and ingress charges potentially. How do you guys handle that, and how do you price that out for customers?
For Jetstream DR, we don't have any cost. We don't charge anything based on storage. We literally license it per protected virtual machines. So the amount of data you use, that's going to be part of the cloud thing. Still important, but that's not an additional charge for us. As far as giving an estimate, again, based on the data set size, we can help with an estimate for what that'll use. In most of the clouds that we are working with, and the one that we do the most business with is the Azure VMware solution. The ingress is not really charged for, so it's going to be egress. So from our perspective, that failover where we're writing into that AVS private cloud, that typically doesn't incur a charge. Now, there still is potentially something with the network gateway, but not a data ingress charge. So we see that as essentially close to free. So when you do that failover test, we're reading out of the object store, writing into that AVS environment. For us, a test failover is the same as a production failover with one key difference. When we fail over in production, we actually immediately resume protection on the recovery side. So if you were to see the process when you're going through the interface to start a failover, we have you specify DR virtual appliance, not because it's needed for the recovery, but it's needed to immediately protect the virtual machine once it's been recovered. So we run through that process. The recovery appliance starts, perform whatever you need with the tests. And then when you're done with the test, so literally in our interface, you tell it you want to complete the test. We'll destroy the virtual machines that were brought up as part of the test. And most importantly, anything you did to those test machines on the recovery side once they'd been powered up is not written back into the object store. So you're just making changes to those machines essentially in a little isolated environment, and then they're destroyed. So from a cost perspective, we're relying on the fact that data isn't charged from Microsoft in that AVS environment. The protection is writing back to that object store, and there's potential cost there. The egress charge would come if you were to do a fail back to the primary site. So in that case, we will be reading the data out of the object store and writing it back to the primary site. And if that's an on-premises site, then there would be charges there. So again, we can give an estimate of the amount of data that would be moved. I will mention that our replication appliances have compression enabled by default. And that's one of the things that we could show you statistically in the interface, how much data is being processed by the DRVA for the virtual machines in a particular domain, and then how much outbound is actually being written. And from there, you'll be able to see the effect of the compression. So again, the cost part's not really built into the display, but the ability to understand what's actually being used is.
Yeah, and if you're failing over in a test, you're probably going to go back to production.
Well, in this case, if you're failing over in a test, you wouldn't necessarily need to fail back, right? The way we envision this use case, and we're not alone in this at all, the protected virtual machines on the original primary site continue to run. They continue to be protected. We're still updating the object store with the changes for those machines. The key for us is that when we do the test failover, they're still protected, still accumulating the changes. It's still being kept up to date in the object store. We'll just bring it up in the test, do whatever you needed in the test, and you wouldn't need to perform a failback. Now, if you wanted to test a failback for sure, then you would have that case. But a normal test of the ability to restore those virtual machines to a recovery site wouldn't require a failback, I don't think, at the end.
And does this support multiple regions at a time? Is it only one region? Can I have a multi-site failover where maybe some VMs go to an east region, some VMs go to a west region?
Yes. So we don't have this concept of pairing, right? So it's not a primary site paired with a recovery site. Since we focus on the cloud-based storage for the protection, you could protect multiple primary sites to the same storage location, the same storage account. So in general, we would think about having that storage site in the same region where you would recover those virtual machines. And the reason for that's just physics. Want it closer to the recovery site because that's where the time is more precious. Typically, however long it takes to replicate, however long it takes to replicate, but however long it takes to recover, the clock is ticking, right? Somebody's waiting, that's impacting availability. So we would have you optimize that. You could have multiple recovery sites as well, pull from the same repository. If you wanted to have different clusters at a particular primary site being potentially recovered to different AVS private clouds, whether those were in different regions or not, they could still use the same storage. We could have more than one storage account configured there that just replicate to the site that they're assigned to. And then you could recover to any target in any region out of that storage site. So again, we don't enforce any pairing. So that ability to have sort of a fan in or fan out, many to one and one to many, it's up to the customer to design that. One thing I'll say about storage, since I neglected to mention this at the very beginning, is because we're using IO filters, the underlying storage that the customer uses for their virtual machines on the primary site or on the recovery site really doesn't impact us. So in other words, you could use NAS, you could use SAN, you could use vSAN on either site, so long as we can access it through the hypervisor, it's presented as a data store through VMware, then we could protect those virtual machines and we could recover to that storage. We looked at it as this idea that there's lots of options. It doesn't have to be like for like on both sides, and anything that we can reach as far as a data store, we could use for protection or recovery.
So I know that Jetstream is storage agnostic, but we are not.
Sure. And neither are customers for that matter, right?
They're not.
That matters. So we'll use what the customer wants to use.
Right. And basically what I'm getting to is it's a good segue into why I asked you onto the Tech on Tap podcast, because during your Cloud Field Day session, you mentioned the magic words Azure NetApp Files as what Jetstream has been using for, I guess, their demos. So talk to me about that. What was the decision behind that? And tell me about your experience.
The original idea behind that is we've got a good partnership with NetApp, and back to this idea of using cloud-based technologies and trying to help with cost efficiency, resource utilization efficiency, and the like. When Azure NetApp Files became available with the Azure VMware solution, then it was natural for us, right? Here's a way now that the customer can scale the storage that they require for this DR or for just for production for that matter, but we're thinking about DR. They can scale the storage for that private cloud without having to add additional AVS nodes, right? So from our perspective, and likely the customer and NetApp's perspective, there's real value here. We could protect a much larger estate with fewer nodes in this sort of steady state environment. It's just protected. We're running it on the primary site. We're replicating out to the object storage. And then for the workloads that have an RTO that doesn't allow for the deployment of a new private cloud, configuring a new network configuration, new network gateways and the like. What we do in this case, advise the customer to create a pilot-like cluster in AVS, size it to what they absolutely need, and then we'll use ANF volumes and ANF storage for that rehydration target for those virtual machines that need to be rapidly available, or if the customer prefers it, just for all the virtual machines. So for us, it was a natural fit, right? It fit with this idea about exploiting some of the key ideas about cloud and then cost benefit for the customer. So that's been it. So the partnership for sure, but it also just seemed natural to us as a way to really provide value for this recovery, which is a cost that's just pure overhead in lots of cases when you think about it against the production virtual machines.
Yeah, NetApp has pretty much traditionally been a way to consume VMware data storage, right? It's been very good for years with that particular workload. So it's a natural fit for this particular use case with Azure NetApp Files. Does Jetstream orchestrate all the creation of the volumes that you need for the Azure VMware solution, or is that something the customer has to stand up prior to this?
So at this point, that's something the customer would do. We'll certainly work with them to size and the like, but at the moment, the current version doesn't do that kind of orchestration. So from our perspective, it has to be created ahead of time. It has to be presented as a data store. And once it's presented as a data store, then when you perform a failover, or even if you do protection, right? Because we could be doing AVS to AVS. So the source is already an ANF-backed vSphere data store. So once it's there, we can go ahead and use it, but we don't orchestrate it. We could advise the customer on what to do. We would consume it.
And is Jetstream aware of any of the other solutions that are integrated with either Azure NetApp Files or VMware, like Storage vMotion or the replication piece of Azure NetApp Files, or is that just something that Jetstream doesn't interact with?
So I'll be careful here, right? In the current version, we don't interact with it. In future versions, we definitely intend to interact with it.
But it makes sense to incorporate those things because they are good technologies, and it is something that Jetstream can leverage to make this whole experience more seamless for your end users.
Absolutely.
When you were doing your calculations for capacity and when you're doing your calculations for IOPS, does it only interact with the VMware piece of that, or does it also interact with the Azure piece through the monitoring tools there to figure out what the ANF side is doing?
With our existing planning tools and the like, we really rely heavily on VMware and vCenter for that. We're not pulling data in from Azure or from the NetApp account or the NetApp volume configuration, so that we would be calculating for the customer. And typically, if we're doing this as a pre-sales exercise, it really comes down to normal planning, right? What are the virtual machines you want to protect? What's that recovery time objective for those virtual machines? From our point of view, we really see ANF as a way to increase the amount of virtual machines that could be recovered rapidly. So this near zero RTO, this continuous failover kind of a scenario, without having to increase the size of the AVS private cloud. So without having to incur that recurring cost of additional nodes. So we're doing that calculation based on how much is the available space on the AVS configuration that's being proposed, how much additional space is needed, and then figure out from there, how much do we skew anything additional toward ANF versus adding more nodes in that planning stage for AVS.
All right. So just to recap, our source can be on-prem or cloud resident, right? So our source VMware data store.
Correct.
Accurate. All right. Our destination is generally going to be in the cloud, correct?
Yeah, the way our solution works, the first destination, if you want to think of that, is always this object store. And then when you perform a recovery, it's the same as before. Anything that's available as a data store on the recovery side is a potential target for us.
Okay. So that tells me that if it speaks S3, even if it's on-prem, you could probably still use Jetstream to interact with it.
Absolutely. In fact, before I came to Jetstream, I worked for a service provider in Northern California, and we did a lot of work for state of California and other customers in Northern California. And in that case, we used our own S3 storage on premises and at remote data centers, and we would protect into that. And we were using Jetstream there. So yes, S3 compatible is the key. It could be on premises, it could be in the cloud. Again, we imagine it in the cloud, but if you're a service provider, you've got your own cloud.
And let's just say for argument's sake that the S3 bucket that you have the VMs being backed up into is also able to be exposed to NFS. Does that simplify the process for Jetstream? Can we just expose that bucket to a VMware data store and be on our way, or does Jetstream still want it to be somewhere else?
So current version of the product, we don't take advantage of that. Future version of the product, that's certainly something we want to take advantage of, right? If we can make it more efficient to get access to that data on the recovery site without having to read it out of the object store and write it into a volume, that would appeal to us. But in the current state, we would always read it out and write it. We wouldn't take advantage of that ability to mount it directly.
Yeah, and that's what I was getting at, because it does sound like something that would be beneficial for Jetstream to not have to move things around, not just for cost, but also for speed. Because if you were able to just turn it on, then you're done, right? And as I understand it, you're only leveraging the Azure VMware solutions for this, right?
Correct. And we've worked very closely with Microsoft to have a solution that's well integrated. So we've really put our effort into that. Other clouds will come later, but for now, it's just a Azure VMware solution. And as you see, if you go to Microsoft, you'll see there's documentation that we've done jointly on how we can be deployed there. And we've done a lot of work with the Azure VMware solution engineers to have an automated lifecycle for Jetstream DR. Every Azure VMware solution private cloud that's deployed comes with a set of commandlets for installing Jetstream DR, doing a pre-flight check. You could add additional hosts, you could add an additional cluster, and we could have it automatically install our software on that. We also can perform updates in AVS through that. We've got a pretty tight partnership with Microsoft on that, and that's where we've been putting our effort.
And as far as getting access to Jetstream, is it something that you download from your site? Is it in the Azure Marketplace? Is it all of the above?
The easiest way to get access to Jetstream is through the Azure Marketplace. You also can make a request on our website. With the Azure Marketplace, any customer has the ability to go on there and create a subscription. And as we said, the actual installation on the Azure VMware solution is automated. You wouldn't even need to download the software to do that. For the on-premises deployment, register with the Azure Marketplace, create a subscription, and at the end of the process, you'll be given a link to download our software bundle. And that software bundle includes the management server appliance that comes as an OVA. That's the main component that you install. Everything else that I described as far as the other appliances and the like, again, that's all orchestrated via the MSA, the management server. You don't need to download additionally any of that. It also includes our admin guide and information about planning, and it comes with our REST API guide. So if you're interested again in those APIs, that's all documented in that download.
And since you have an on-prem solution, does this integrate well with, say, dark sites, right? Like government contractors that need to have segmented networks not connected to the internet? Is that something that can be done with Jetstream today?
Yes. In that case, we would be relying on the customer to provide all of the connectivity the way they need it. We can support on-site S3 or on-site object storage. We can support completely private object storage. So whatever they have in the environment, the keys for us are going to be, it's got to be a VMware environment. We have to have the ability to read the storage where the virtual machines are there. So again, back to the VMware thing, as long as it's a data store that we can access, then we've got that. As far as the protection, we write to that object store. So whatever path the customer needs to whatever storage for that object storage that they need, we'll be able to write to that. And then same way on the recovery, as long as that path exists, we're not operating our own management tier in the cloud and then connecting to it. So it's all contained within the customer's deployment.
Okay, good. So you can basically have a self-contained Jetstream instance, not have to connect to the cloud at all, and it still works.
Yeah. I would say there was one case where if you are going to use an Azure storage account for the object store, then you will have to connect to a monitoring server that we have in Azure, and that's all documented. That would be the case. But if you didn't use an Azure storage account, it's completely self-contained.
All right, sounds like we got a pretty good solution here for backing up your Azure VMware solutions with Jetstream Software. So, Dennis, if I wanted to find more information on all this, how would I go about that?
The best place to go is our site, jetstreamsoft.com. And from there, you can look at solutions, the product, support information. It's all there. That's the best place. There are some additional resources that I'll share with you and you can put into the blog post for this.
All right, excellent. Again, if we wanted to reach you, Dennis, how do we do that?
Easiest way to reach me, email, it's dbray, D-B-R-A-Y, at jetstreamsoft.com.
And the Cloud Field Day presentation, I would imagine, is already up and available to be watched. I guess it was recorded, so we'll also include that in the blog as well.
Yeah, you can get that off of our site as well. But yeah, the Cloud Field Day link is probably the best place to get that.
It'll even have pictures.
Pictures. You'll see me performing the demo.
Doing the song and dance, the try to stump the field day delegates or not be stumped by them.
Yeah, I worked for years actually as a VMware instructor. And in every class, there was that inevitable moment where it was going to be, I used to call it stump the chump. Somebody in the class was going to see if they could get me. And I always loved it, right? A question that I can't answer just made it more interesting in class. Mm-hmm. So that's just part of the deal.
Yeah, they know their stuff and they definitely are trying to get the most out of that presentation. But yeah, they are kind of known for making you sweat a little bit.
Yeah, to be fair, though, they're doing that with the audience in mind. And even in the case of us, they help to bring out things that we may not have thought to mention.
Yeah, absolutely. Or for roadmap stuff, like, oh, we didn't even think to consider that. And that's a good thing to put on a roadmap.
Yeah.
All right, cool. Well, thanks again, Dennis, for joining us and talking to us all about Jetstream Software, as well as how you're using Azure VMware solutions with Azure NetApp Files.
All right, that music tells me it's time to go. If you'd like to get in touch with us, send us an email to podcast@netapp.com or send us a tweet @netapp. As always, if you'd like to subscribe, find us on iTunes, Spotify, Google Play, iHeartRadio, SoundCloud, Stitcher, or via TechOnTapPodcast.com. If you like the show today, leave us a review. On behalf of the entire Tech on Tap podcast team, I'd like to thank Dennis Bray of Jetstream Software for joining us. As always, thanks for listening.
Oh, yeah. Is it just me that's getting off on this? Oh, yeah.